All right, so our last video had to do with solving systems by graphing. So today we're going to talk about solving systems by elimination. And if we're being honest, this to me is the most fun. I find a lot of joy and fun in doing the elimination ones. So just recall that solutions to systems are points like x, y, that both equations or lines have in common, and they are two numbers that satisfy or work in both equations. They make them work. So a couple of vocabulary words that we are going to need to know when we dive in are what a constant is and a coefficient. So a constant is just a number with no variables. And our coefficient is a constant in front of and multiplied by a variable. So an example of a constant is just 3. Okay? An example of a coefficient would be something like the 3 that comes in front of an x. Okay? So what is the elimination method for systems? It's a method of solving systems of equations where both equations are added together to eliminate or cancel a variable that has the opposite coefficients. So you'll notice we have, in this example, we have x plus y equals 4 and x minus y equals 2. So what we're going to do is we're going to add them together going down in columns. So x plus x is 2x. Y minus y is 0, and 4 plus 2 is 6. So the y's cancel out, so you're left with 2x equals 6. Okay, so that's an example of an elimination. Okay, so how exactly do we use elimination to solve a system? Okay. So first, we need to make sure the equations are lined up the same way. So we want the x's to line up with x's. We want the y's to line up with y's. Okay, so step 1, we multiply, if necessary, one or both equations by a constant, okay, to make one of the variables have opposite coefficients. Okay, so an example would be 3x and negative 3x, so they're opposites here. Okay, after we multiply, if we have to, we add the equations together to eliminate one of the variables. Okay, we solve the resulting equation for the one variable that remains. Okay. After we solve, we might get x equals a number, y equals a number. Then we substitute the value of the variable from step 4, substitute or plug in, okay, into one of the original equations and solve for the other variable. Okay, we can always check and double check if we got the right answer if we want to by plugging it into both equations. Okay, so special case. What if both variables are eliminated? Okay, if both variables are eliminated, the answer will be no solution. If you are left with a false statement. So an example of a false statement would be 0 equals 8. Okay, that's a false statement because we know that 0 doesn't equal 8. All right, so our answer would be no solution. Or we could have infinitely many if we are left with a true statement. So something like 0 equals 0. Okay, so that's true. So we have infinitely many solutions. Okay, so a couple of examples. Let's go ahead and look at this one. Okay, we're going to solve these. We actually already looked at this one up here. We're just going to work through it and solve it. Okay, So we have x plus y equals 4 and x minus y equals 2. So everything's already lined up. There's nothing I need to multiply here because I can tell that the y's, there's a positive y and there's a negative y. So I know that they're going to cancel first. Okay, so I'm going to add straight down. So x plus x is 2x plus 0 equals 4 plus 2 is 6, which is the exact same thing as 2x equals 6. So to get x by itself, we divide by 2. So x equals 3. Okay, so now that we have this, now plug x into one of the original equations. Okay, so if I'm solving for y and I want to get y by itself, I'm probably going to plug it into the original, like the first question or the first equation where y is positive. So I have x plus y equals 4. So if I plug it in for x, it becomes 3 plus y equals 4. So to get y by itself, we subtract 3 from both sides. So y equals 1. Okay, so you'll see I have x equals and y equals. So my solution is 3, 1. Okay, so let's look at a couple of other ones. Okay, solve each system by elimination. So step 1, I have x plus 2y equals 4, and I have x minus y equals negative 5. Alright, so if I were looking at this, the first thing I notice is that I have 2 positive x's and I have a positive y and a negative y. So one is positive, one is negative, so those are the ones I'm going to work with. What I do notice, though, is that this has a 2 in front of it and this one doesn't. So I am going to multiply by 2. Okay? So this one's going to stay the same. We have x plus 2y equals 4. And so when I multiply by 2, everything gets multiplied by 2 inside the parentheses. So we're going to distribute that 2 to everything. And it becomes 2x minus 2y equals negative 10. Okay, so that's what happens after we after we multiply. So now I'm going to add these together. Okay, so x plus x, so x plus 2x is 3x, positive 2 and negative 2 is just 0, equals negative 6. So this is the same thing as 3x equals negative 6. So if I solve for x, I get that x equals negative 2. So this is where now I'm going to take it and plug it back into an original equation. And I'm going to use the top equation. Can I use the bottom one? Absolutely. Do I have to? No. Okay. So we have x plus 2y equals 4. I'm solving for x, duh. Okay, my bad. So x is negative 2 plus 2y equals 4. Okay, so to get y by itself, we're going to add 2 to both sides. So 2y equals 6, y equals 3. So my solution is negative 2, 3. Okay? Looking at this one, we have negative 2x plus y equals negative 6, and we have negative x plus 3y equals 3. Kind of the same situation. The first thing I noticed is this has a negative x and this has a positive x. This is a negative 2, this is positive 1. I think it would be easier to just multiply this entire equation by 2. Okay, so the top equation is going to stay the same. Negative 2x plus y equals negative 6. So this bottom equation, when I multiply by 2, becomes 2x plus 6y equals 6. And I can add everything together. Okay, so the x's cancel out, plus 7y equals 0. So I have 7y equals 0. To get y by itself, we divide both sides by 7. So y equals 0. If I plug it into an original equation, so we have negative 2x plus y equals negative 6. So if I plug that in, we get negative 2x plus 0 equals negative 6. So negative 2x equals negative 6. X equals 3. So my solution is 3, 0. Okay, let's look at number 3. So we have 5x plus 2y equals 7, and 7x plus 6y equals negative 3. Okay. I think what I'm going to do is I'm going to try to eliminate the y values. And in order to do that, I see that one has a 2 and the other has a 6. The one way that I can think of off the top of my head to do that, so that way the 6 y's cancel, is I'm going to first have to multiply the top equation by 3. But to make this a negative 6, I'm going to have to multiply it by a negative 3. So when I multiply straight through, I get negative 15x minus 6y equals negative 21. And then the bottom equation is going to stay the same. So we have 7x plus 6y equals negative 3. Okay, so when we add, those cancel. Negative 15 plus 7 is negative 8 equals negative 24. So when I divide both sides by negative 8, x equals positive 3. Okay? Now, it doesn't matter which one of these equations I choose to plug it into, but if I choose to plug it into the top equation, we're going to focus on the original equation before we multiplied it. So that 5x plus 2y equals 7, that's what I'm going to plug it into. And I'm going to make sure that it takes the place of that x right there. Okay, so we're going to have 5, which is 2y equals 7. So this is going to be a 3. Okay, so we have 15 plus 2y equals 7. If I subtract 15 from both sides, I get 2y equals negative 8. Divide both sides by 2, so y equals negative 4. So the solution would be 3, negative 4. Okay. All right, so let's look at number 4. 2x plus 4y equals -1, 3x plus 5y equals -2. Which one do I want to cancel out? I want to cancel out the x's. Let me show you what that looks like when we cancel out the x's. So to cancel out the x's, one needs to be negative, the other one needs to be positive, and they both have to have the exact same coefficient. So the easiest way for me to do that, to have the same coefficient, is to multiply this one by 3, and to multiply this one by -2. Because if I can do that and distribute these all the way through, so 3 times 2 gives me 6x plus 12y equals -3. And the bottom one gives me -6x minus 10y equals 4. Now when I add these together, the 6's completely cancel. 12 minus 10 is 2y equals +1. So to get y by itself, we're going to divide by 2. So y equals 1/2. Okay. So one of the things that we can do is we're going to focus and we're going to plug it in to this equation right here. The original equation pre-multiplication. And the reason why is because 1/2 is positive and it's even, and this number 4 is even. Okay? And you'll see it's actually going to help us out a lot that we pick that equation. So 2x plus 4y equals -1. So 2x plus 4 times 1/2 equals -1. So we get this 2x plus 2 equals -1. 2x equals -3. X equals -3/2. So our solution -3/2, 1/2. Okay. So let's look at number 5. I think it might be easiest to get rid of our 8s, or I should say our 8. Oh, I can talk today. It's fine. We should be able to get rid of our x's. So that's a +8, that's +4. So I'm going to go ahead and multiply this top equation by -2. So I end up with -8x plus 6y equals -4. Yeah, 2 times -2 is -4. And the bottom equation stays the same. So I have an 8x, that's +8, minus 6y equals +4. So when I add it all together, everything cancels. So I'm left with a 0 on this side equals a 0 on this side. So when everything cancels, CLS cancels. I think that's how you spell it. If not, oh well. When everything cancels and you're left with 0 equals 0. Whenever that is the case, you will always have infinitely many solutions. That just means if we were to graph these, if we were to solve it by graphing, it'd be the exact same line. They'd be two different lines on top of each other. Okay, number 6. I think it's going to be easiest to cancel out the y's. And the reason why, is this is a -2. That means I only have to change that y to a +2. And in order to change it to a +2, I multiply by a -2. Okay? So when I multiply by a -2, we get -4x plus 2y equals, what is that, -4. The original equation is 4x minus 2y equals 12. So when I add these together, almost everything cancels. So these cancel on the left-hand side. Those cancel out, which gives me a 0. But on the right-hand side of the equal sign, that doesn't cancel out. That gives me an 8. Okay? These are not equal. Okay? So when I have a false statement, just like I have right here, false statement, we have no solutions. Okay, let me know if you have any questions.